to monitor flow pressure between two sensors and let's say interfaces of the system. So we have created a model for that, and if the flow pressure is different within tolerance, then we want to check requirement that it is satisfied. Also, there is rule that we need to monitor this flow pressure and check the requirement only when the valve is open. When the valve is closed, this requirement is satisfied by default. So for this purpose, we created this model. We see here sensor in the system. We see valve. Valve has open property. Sensor has pressure, and there could be more components, and this is just part of that system which would provide that pressure information, but in our case we don't need them, just to show the solution for that. Here also we created a constraint lock, which is just to check that once the valve is open, pressure difference shall be less than tolerance. If the valve is closed, we don't care about pressure difference. So tolerance is property of the system. And also we refine requirement by this constraint. So this constraint formalize this requirement. So requirements pressure difference is in limits. If valve is open, pressure measured by two sensors shall be within allowed tolerance. So next we create a parametric diagram in this system, or in some analysis block which would have the system as a part. So this is a simple parametric diagram which has the input from all parts, like properties pressure 1, pressure 2, and then Boolean property of valve open. We have the constraint, which is in JavaScript. This is the syntax of JavaScript, and then we have tolerance coming from the system. And next we can run this one and run. Yes. So we get the requirement satisfied with those conditions. So pressure 100, tolerance 5, requirement is satisfied. We see that this requirement is satisfied. Now if I will input some different pressures, I will get the result, right? So requirement is not satisfied because the tolerance is less than the difference here. If I will change the pressures, like here, this one will be higher, this will be lower, still works, right? Because this checks the absolute difference. And then if valve is closed, we get this requirement satisfied, right? If valve is open, again we have different situation. And now if I will increase the tolerance, still doesn't work. 8, still doesn't work. 9, requirement is satisfied. Now I can save the results to the instance. Save configurations, okay. And I can open instance model. I can create instance table. I can set the scope as the configurations. I can set this classifier as the system here, and I will see all the pressures and all the situations here. So with those inputs, I will see false and pass result. If I will change some inputs, like for example 4, 2, 1, I can select them and solve them again. You see that this became false, and it didn't satisfy requirement anymore, right? If I will change the tolerance again, it will be recognized. So those instances are different configurations, and that's how I can do trade-off. Actually, if I would have more properties, I would be able to pick the best configuration which would satisfy this requirement, at the same time would be maybe less expensive or more reliable. That's how we can do trade-off, by sorting by right property when we do analysis, but it should this configuration satisfy all the requirements.